Hello everyone. Today we will start alternate to practical Feb March 2023. So let's have a look. Long chain alkanes can be broken down into shorter chain alkanes and gaseous alkanes. Vapor form a long chain alkane is passed over a very hot catalyst and the gases formed are collected over water. The apparatus used here is shown. So you can see the apparatus which is shown here. The gases are collected under water. Name the term of apparatus labeled A. So here A is known as water bath, or you can also write as trough. The catalyst is small pieces of aluminum oxide. Explain why several small pieces of aluminum oxide speed up the reaction more than one large piece of aluminum oxide. So we know that small pieces will increase the surface area. Okay, so that is the correct answer. Name the item of apparatus that can be used to heat the long chain alkane and catalyst. So what we use for heating is normally an Bunsen burner. Add two arrows to show where the apparatus should be heated. So in the apparatus here we'll heat this alkane and the catalyst. Okay, so two arrows we have to show. The gas collected is tested using aqueous bromine. Alkenes turn aqueous bromine from orange to colorless. When the first bubbles of gas collected are tested, the aqueous bromine does not change color. Explain why the aqueous bromine does not change color. So in the test tube, air is also present, okay, because of which few bubbles which are coming first are air. That is why it is not changing the color. As soon as the experiment is over, the heating is stopped. The delivery tube must be removed from water. Explain what happens if the delivery tube is not removed from the water as soon as heating is stopped. So the water may go back to the tube and it may break or crack. Question 2. A student investigates the solubility of ammonium chloride in water at different temperatures. The student does 5 experiments using the following instructions. Experiment 1. Fill a burette with distilled water. Run some of water out of the burette so the level is adjusted. Use the burette to add 8 centimeter cube of distilled water to 5.25 grams sample of ammonium chloride in a boiling tube. Clamp the boiling tube at an angle as shown. So in the test tube, they have taken some amount of ammonium chloride and they have added around 8 centimeter cube of water and they are started heating the test tube. Okay, they are heating it till the ammonium chloride is dissolved. Now continuously stir the solution with thermometer while it cools. Measure the temperature of the solution as soon as the solution becomes cloudy and solid starts to form. So we have to measure the temperature when again the ammonium chloride is starting to form. Okay. In second experiment, use the burette. Again, we will add only 0.5 centimeter cube of water and we will perform the same procedure. We are going to repeat it more 3 times. Okay. And in every experiment, we are going to add 0.5 centimeter cube of distilled water to the boiling tube. So here a table is given where mass of ammonium chloride, which will remain constant, that is 5.25 grams throughout the experiment. Total volume of water which is used. So in first experiment, they have given, which they have used 8 centimeter cube of water. In the second experiment, we have observed that they are adding only 0.5 centimeter cube. So total water which is present in the tube is 8 plus 0.5, which gives us 8.5. Okay. The remaining, every time I told you that 0.5 centimeter cube of water is added in every experiment. So we will add 0.5 and it comes to a total 10 centimeter cube of water. Next is thermometer. So the diagram is already shown, and looking at the diagram, we have to write the temperature here. So observe the temperature properly. If it is in 0.5, write it in 0.5. And whenever it is in decimal, we have to always write a 0.0. Okay. So if it is a whole number, we should not only write the whole number, we should already write 67.0. We should write the decimal place also. This whole column will score you 1 mark, and if it is not written properly, it may happen that they can cut your marks. Compare a suitable scale on the y-axis and plot your results from experiment 1 to 5. Draw a line of best fit through all your points. So here, according to our points, okay, we are going to take, so already they have given us the x-axis and y-axis, already they have started from 30. So accordingly, you will take the points. I have taken here difference of 10, okay. And then after plotting all the points, I have just connected all of them and extended here. Now, extrapolate the line on your graph and reduce the temperature when a solid starts to form when a total volume of 10.5 centimeter cube of water is used. Now here I have to find out 10.5 centimeter cube, which is on x-axis. So from there I will plot a straight line touching towards the curve, and from there I will again plot a horizontal line towards y-axis, and here somewhere I get my answer, which is 44.5 degrees Celsius. Solubility in gram per 100 centimeter cube of water is calculated using equation shown. Solubility is equal to mass of solid dissolved into 100 upon volume of water used. So already the formula is given and they are asking you to calculate this for experiment 1. So here mass of solid dissolved, mass which is used is common constant, that is 5.25, into 100 remains as it is upon volume of water used. So we have different volumes. We have added different volume of water, but they have specifically asked for experiment 1. In experiment 1, we are using 8 centimeter cube of water. So that is why we have written here 8. After calculating, we get an answer of 65.625. Okay. So for such kind of questions, whenever the formula is given, read the question properly. For which experiment they are asking you, just by substituting, you are going to get your answer. Describe how the solubility of ammonium chloride changes as the temperature changes. So it is simple. If you increase the temperature, the solubility will increase, or vice versa. Also, you can write down if the temperature decreases, solubility also decreases. Both ways is correct. In this experiment, the volume of water was measured using a burette. State the advantage of using a burette rather than a measuring cylinder to measure the volume of water. So always using a burette over a measuring cylinder or a pipette is, it is more accurate. So that is the same answer. Mostly this question is asked in many of the ATP papers. State the advantage of using a burette rather than a volumetric pipette to measure the volume of water. So here, as they have asked you specifically that why we are not using a volumetric pipette. Okay. So both burette and pipette are accurate than measuring cylinder. But in this case, when we have to add variable volumes, okay, so a pipette, a volumetric pipette is either of a 5 centimeter cube or 10 centimeter cube, okay. But when we have to add different volumes, so that we can add easily once we fill the burette, okay. So that is why we are using burette, as it is used to measure variable volumes here. We can take different measurements of volume. A total volume of 2 centimeter cube of water was added to the original 8 centimeter cube of water. Explain the disadvantages of adding the 2 centimeter cube of water in 1 centimeter cube portion rather than 0.5 centimeter cube of portions. So here, if we observe the table, in each experiment, we are just adding 0.5 centimeter cube of water. Okay, so total is 10 centimeter cube of water which is present in the boiling tube. The question is, instead of 0.5 centimeter cube, if we directly add 1 centimeter cube of water, like if it is 8 centimeter cube, I will directly add 1 centimeter cube of water, then it will become 9. I will directly add 1 centimeter cube of water, it will become 10. So because of which, what will happen? We will get very few data. Okay, we will get very few points, and we will not able to plot the graph properly. So the results will be poor. Suggest why it would not be possible to use 6 centimeter cube of water instead of 8 centimeter cube of water in experiment 1. So if we are using less volume of water, it may happen that ammonium chloride will not dissolve. Okay, so that can be a problem. That is why we are using 8 centimeter cube of water here. In question 3, we are having a qualitative analysis question where the student tests two solutions, solution C and D. Solution C is aqueous calcium nitrate. So it is already mentioned in the question that it is calcium nitrate. Complete the expected observations. First question, the student carried out a flame test on the first portion of solution. Now they are carrying a flame test. So here we already know the compound, which is calcium nitrate. So as it is calcium, the color of the flame will be orange red. To the second portion of solution C, the student adds aqueous sodium hydroxide dropwise until it is in excess. So here we are having two observations. First, dropwise addition of NaOH, and second, excess addition of NaOH. So when we are adding it dropwise, first of all, it will give us a white PPT, and later on, by adding excess of NaOH, the PPT will not dissolve or it will remain insoluble. So this observations, from where do you get it? Here in the ATP paper, they give you this qualitative analysis at the end of the paper, which is this. See, so here now, as calcium is a cation, you can see it is here. So here, calcium, first it gives a white precipitate and then insoluble in excess, which is already written here. To the product from B, the student adds a piece of aluminum foil and warms the mixture gently. Any gas produced is tested. So when the test is for aluminum foil, when aluminum foil is added, okay, and when the compound contains nitrate, it means ammonia gas is produced, and the observation would be damp red litmus turns blue. Okay. Now here many students get confused when they are asking any gas produced is tested. So they write the name of the gas which is produced. So students write ammonia, which is wrong. They are asking the test which they have performed. What are the observations for that test? So the observation is damp red litmus paper turns blue. Okay. To the third portion of solution C, the student adds about 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous silver nitrate. Now, dilute nitric acid and silver nitrate test is actually for halogens. In this compound, calcium nitrate, no halogen is present, because of which we will write no change here. Now, test on solution D. Use a glass rod to transfer 1 drop of first portion of solution D onto a piece of universal indicator paper. So here the observation is it turns red. Okay, now as it turns red, what we can infer from this, that it can be an acid. To the second portion of solution D, add solid sodium carbonate. So here effervescence is seen and the gas turns lime water milky. So lime water turns milky is a specific test for carbon dioxide. Again, you can use that qualitative analysis chart for this. So this is for anions. Okay. See, here we are having carbon dioxide, where it will give lime water turns milky. And in anions also, I guess we are having carbonate, first one itself, where it effervescence is produced. Okay, so whenever carbonate is there and when lime water turns milky, you have to remember that carbon dioxide gas is released. To the third portion of solution D, add 1 centimeter depth of dilute nitric acid followed by few drops of aqueous silver nitrate. So again, dilute nitric acid and silver nitrate test is performed here. Just now in the above test, we saw that as this test is for halogens, there are no halogens present, because of which they have given no change. Okay, so it means that there is no halogen in the compound. To the fourth portion, they are adding nitric acid and barium nitrate. So this test is for sulfur dioxide. Okay. So white precipitate is given. Again, if we want, we can check in the qualitative analysis chart. See, it is this one. Acidity with nitric acid and aqueous barium nitrate, which gives a white precipitate. So it is a sulfate. Okay. Sorry, I said sulfur dioxide. This is a sulfate ion, SO4 2 minus. Okay. So that you have to remember. Now, deduce the pH of solution D. As we saw that the color of the universal indicator paper was red. So the range can be either 1, 2, 3. Okay. They have clearly mentioned it universal indicator paper. So we have to write the pH number proper. Identify the gas made when sodium carbonate is added to solution D. So we saw that lime water turns milky and it is a test for carbon dioxide. So the gas produced here was carbon dioxide. Identify two ions in solution D. Now, two ions which are present. So from this universal indicator turning red, I told you that it can be an acid. Okay. So acid contains which cations? Always H plus. And the second one, that is anion, we get it from this test 4. Okay. So that was sulfate ions. So it is H plus and SO4 2 minus ions present. Okay. Next, plan an investigation question. Cadmium, cobalt, and vanadium are all metals. They react with dilute hydrochloric acid to form hydrogen gas. These reactions are exothermic. Now, in the question, they are giving you some hints. So, first hint which they have given is that this is exothermic in nature, and they all are reacting with dilute hydrochloric acid also. Okay, and hydrogen is being formed here. So, these are the three hints which you are already having in the question. Plan an investigation to find the order of reactivity of three metals. Your plan must make it clear how your investigation will be a fair test and how you will use your results to place the metals in order of reactivity. You are provided with powdered samples of each metal, dilute HCl, and common laboratory apparatus. So here you are having two methods, okay, two easy methods to write this investigation. So as I told you in the question, they have given that the metals are reacting with HCl. Also, it is producing hydrogen and the reactions are exothermic in nature. So two methods you can use here is either you can measure the amount of gas, hydrogen gas, which is produced. Okay, that is one method. And second, you can measure the temperature. So as this reaction is exothermic in nature, you can measure the temperature and you can find out the compound, the metal which will having a higher temperature change will be more reactive. So how we are going to write it? So if you are choosing this method of gas collection, how you will write? Now, first of all, you have to select an apparatus in which apparatus you are going to perform, whether it is a test tube, a beaker, a conical flask, etc. So you have to mention the apparatus. So we are going to perform it in a flask. Okay. We will add around 1 mole per dm cube. Here, the concentration of hydrochloric acid is mentioned. Okay. So we will add 1 mole per dm cube of known volume of hydrochloric acid. Again, we have to weigh the metals. So also the amount is stated, that is 1 grams of cadmium is added to the flask. Okay. Now, as we are using a gas collection method, so to the flask we have to attach something we will collect, which will collect the gas. So we are attaching a gas syringe to the flask that will collect the hydrogen gas here. Okay. Repeat the same with other two metals. Now, the metal that produces more volume of gas is more reactive. Okay. So here the metal which is going to produce more amount of hydrogen gas in a limited time will be more reactive metal. So this was the conclusion that how your method tells us about which metal is more reactive. Okay. So it should be clear from the method which you are using. Next is temperature change method. So starting remains same, that you are going to perform into a suitable container. You are going to add some amount of this much amount of HCl. You are going to add this much amount of your metal. Okay. Now measure temperature of HCl. Now before adding the metal, you are going to measure the temperature of hydrochloric acid, which will become your initial temperature. And after the reaction, like after adding cadmium, after the reaction is completed, you will again measure the temperature of the reaction, which will become your final temperature. So what you will do, repeat the experiment with other two remaining metals, and what you will do is final temperature minus initial temperature will give you a difference between the temperature. Okay, now you have to do it for the other two metals also. And finally, you can find out the element which is having higher temperature change is the more reactive element. Okay, so this is how you have to write it by mentioning the apparatus name, what is your method, which method you are using, and after using the method you have selected, how you are going to conclude, like how you will understand that after using this method you will understand this, these are the results. Okay, in some cases, in some plan and investigation, if required, you can write the formula also, you can draw a table also. So this is how you will solve this plan and investigation question.